Hello students. Hello and welcome to this video. In this video, we will solve question number 513 to 525, which will finish the permutation and combinations chapter for us. And we will move on to mathematical induction after that. The link to download the PDF will be in description, as well as at the end, I will show you how we can maintain an updated copy of the books. I will also show you my question answer website where you can come and ask your questions. I will be able to answer you over there because YouTube comments are not really suitable for mathematical content. So without further ado, let's get started. Question 513 says that given any five distinct real numbers, prove that there are two of them, say x and y, such that 0 less than x minus y over 1 plus x times y less than 1. So what we do is we choose a is equal to tan a in the range minus pi by 2 to pi by 2. The reason we chose this is because the tan function in this range is strictly increasing and covers the complete range of real numbers. Now we divide the interval into 4 equal intervals, each of length pi by 4. And we apply pigeonhole principles, and we find that at least two of the values lie in the interval such that it falls in one of these. Let's say we call this x and y. And these will be such that 0 less than tan inverse x minus tan inverse y less than pi by 4, which implies that 0 less than x minus y by 1 plus xy less than 1. So it is not really easy question. I will classify this as a hard question because it is counterintuitive to figure that when basically it is not even permutation combination question. I wouldn't classify this as one. Question 514 says that prove that among any 52 integers, 2 can always be. So the last question we can classify it as combinatorics question because it makes use of pigeonhole principle. So question 514 says that prove that among any 52 integers, 2 can always be found such that the difference of their squares is divisible by 100. So we let the two numbers be x and y. According to question, x square minus y square is equal to 100k, such that k is in the set of natural numbers and xy is in the set 0 to 100. Clearly, x plus y into x minus y is equal to 100k. Since the numbers are between 0 and 100, so the sum is going to be divisible by 100. Okay. Let us pick these pairs. 0, 0, 199. This should be 100, right? This should be 100. 199, 49, 51, which is 50 pairs. Okay. Once we have the 50 pairs, this is 100, okay? This is not 0, 0. So we can pick one of these 50 and extra 50. 50 number is not part of any pair. So 50, one of 50 from these, and then the remaining 50. So we choose 51 numbers. But the moment we choose 52nd number, that will be part of one of the pairs whose sum is 100. And that's how we get the result. Question 515 says that there are 7 persons in a group, so that some 2 of them have the same number of acquaintances among them. So case 1, when each person has at least one acquaintance. In this case, a person can have 1, 2, 3, up to 6 acquaintances. But we have 7 people, hence the result from pigeonhole principle. Case 2, when a person can have 0 acquaintances, assume that one person has 0. So effectively, we can remove him from the group. Thus, we are left with 6, and like case 1 from pigeonhole principle, we have the same result. Question 516 says that 51 points are scattered inside a square with a side of 1 meter. Prove that some set of three of these points can be covered by a square with side 20 centimeter. So what you can do is you can divide 1 meter side into smaller squares of side 20 centimeters. So you'll get 5 by 5, that is 25 squares you will get, right? Yeah. So once you have 25, you can put 2 points in each of the squares. That will be 50. And then 51st point will, when you'll put in any square, will have at least 3 points. So that's how we solve this. Question 517 says that let 1 less than A1 less than A2 and so on up to less than A51. This should be subscript. Less than 142. Prove that among the 50 consecutive differences AI minus 1, where I varies from 1 to 51, some value must occur at least 12 times. So we try to add smallest differences 11 times. Then we have 1 plus 2 plus 3 plus 4 times 11 plus 5 into 6. That is 140. The difference 5 occurs only 6 times because we have 44 differences already. Thus, if we pick 51st number, then one of the differences which we have already taken will appear, making it 12th one from the pigeonhole principle. And very well. Question 518 says that you are given 10 segments such that every segment is larger than 1 centimeter but shorter than 55 centimeter. Prove that you can select 3 sides of a triangle among these segments. So this is 518, right? Let the sticks or line segments be S1 through S10 according to question 1 less than S1 less than equal to S2 and so on to S10 less than equal to 55. Let us assume that triangles are not possible, then 2 plus 2 less than equal to S1 plus S2 less than equal to S3. So S3 is greater than 4, greater than equal to 4. Similarly, we find S4, S5 and S10. We find that S10 greater than 55, which is a contradiction, has been resolved. Question 519 says that there are n cells in a 3 by 3 square. When these cells are filled by numbers 1 to 3 only, prove that of the 8 sums obtained, at least 2 sums are equal. So the sums are that of 3 row columns and 2 diagonals. Minimum value of these sums is 1 plus 1 plus 3 and maximum is 3 plus 3 plus 9. Thus, we have only 7 values for 8 sums. Hence, from pigeonhole principle, 2 sums must be equal. Question 520 says that let there be given 9 lattice points with integral coordinates in 3-dimensional Euclidean space, so that there is a lattice point on the interior of one of the line segments joining 2 of these points. We consider a lattice point, classify it according to parity, oddness or evenness of its centers. There are exactly 8 different ordered triplets of even and odd. Thus, 2 of the 9 given points must have the same parity. How did we get 8 here? The coordinate can be odd or even, so there are 2 choices. 2 to the power 3 is 8. Suppose that x, y, z and ABC are 2 points such that each coordinate has the same parity. Then x plus a by 2, y plus b by 2, z plus c by 2 are all integers and are the coordinates of the midpoints of the line joining x, y, z and ABC. This is not at all. This midpoint is a lattice point on the interior of the line segment joining x, y, z and ABC. So if the parity is same, then x and a are either odd or even, both of them. And thus the x plus a by 2 will be integral. Okay? If both are odd, some will be even. If both are even, some is even. And that is why we will have integral points for these. Question 521 says that consider 7 distinct positive integers not exceeding 1706. Prove that there are some of them, say a, b, c, such that a less than b plus c less than 4a. So let's assume first two numbers are 1 and 2. So then we apply the rule x is equal to x minus 1, which gives next numbers as 7, 21, 107, 427, and 1707. If this is the case, then triplets cannot be found, but such is not the case, hence the result. Question 522 says that consider a circle C with a radius 16 and an annulus or ring A with an outer radius of 3 and inner radius of 2. Prove that wherever one might sprinkle a set S of 650 points inside C and annulus A can always be placed on the figure so that it covers at least 10 of the points. So we consider this, this is the question. So we draw a ring of given radii around every point. These rings can be contained within a circle of 19 and area 19 square pi. The sum of all the rings is 650 into 3 square minus 2 square pi, which is more than 9 into 19 square pi. And hence, from the pigeonhole principle, we have the result. Question 523 says that on a rectangular table of dimension 120 inch by 150 inch, we set 14,001 marbles of size 1 inch by 1 inch, so that no matter how these are arranged, one can place a cylindrical glass with diameter 5 inch over at least 8 marbles. So proceeding like previous problem, we put cylinder around all those 14,001 marbles, giving us a total area of 14,001 multiplied by 25 by 4 pi. This would be contained in rectangle 125 times 155, which is more than 12 inches, 12 times the area covered by the cylinder, and hence very well. Question 524 says that if a line is colored in 11 colors so that there exist 2 points whose distance apart is an integer which have the same color. So we consider any 12 points on the line. Since we can have only 11 colors, at least 2 points must be of the same color whose distance apart is integral. Question 525 says that so that given 12 integers, there exist 2 of them whose difference is divisible by 11. So mod 11 will divide the difference into 11 equivalence classes. 2 numbers are of the same equivalence, A is equal to B is equal to M, where M is M divides A minus M. So when we will choose 12 numbers, 2 of them will fall in the same equivalence class. In other words, the remainder can be 0 to 10. Out of these, only 10 remainders will satisfy the criteria, that is 1 to 10, which we can get by using 11 numbers. 12 will always fall in one of those 11 classes, and thus difference will be divisible by 11. So with this, we come to the end of permutation and combinations. Let me quickly show you how you can download the books. You need to go to my website, astrology.org, and you can download Algebra, Trigonometry, and Coordinate Geometry from second, third, and fourth link respectively. The PDF will not have the date time, which you need to add manually. The reason is, whenever I update the PDF, this date gets updated, and you should revisit the website once in 15 to 30 days, and you will see that the PDF, if the date has changed, you can download it. I cannot put the date in the actual file because I will have to update all the YouTube descriptions with updated links all the time, which is practically infeasible for me. The second thing is that you can come to the web application which I have created for you, that is kumrika.astrolog.org. You can make a login here and ask questions, and I will be able to answer your questions. You should make use of tags like algebra, calculus, trigonometry, or coordinate geometry, or geometry. So these subject questions will be answered. All right. So with this, I will end this video here. I hope that you are enjoying this playlist and finding it useful. Next topic is mathematical induction, and we will start that tomorrow. So thanks a lot for watching the video. I wish you all the very best in your studies. So keep learning, and I'll see you in the next one. Till then, enjoy and have a nice day.